A very good morning. In today's class, we are going to see about the principles of air sampling. Before we go into the principles of air sampling, we should know what we should carry when we go for an air sampling. When we go for an air sampling, it is very important to carry a field notebook. You should write the place of air sampling, the duration of air sampling, and also you should take an ethanol and cotton for surface sterilization of the samplers. You should have a marker when you go for a sampling, and where you have to pack these samplers in a box, and you have to take it carefully to the area of sampling. So all these things you have to take when you're going for an air sampling. And what is very important is when you're taking an air sampler, when with the help of an air sampler, when you're taking air samples, it is very important that there should not be any obstacles near the air samplers. So especially when you're sampling at indoor environments, you should not keep the samplers near to the walls and do the air sampling. So the air sampler should always be kept in the center of the room while it is in operation. So these air samplers can be categorized into various methods. So the air samplers, how it is categorized into various methods of air sampling is as follows. It is being categorized into 6 types. First is the sedimentation method. In the sedimentation methods, we'll see about the gravity petri dish method of air sampling, then gravity slide method. Here, the airborne particles which is found in the atmosphere, whether it is a bacteria or fungi, it gets settled onto a sticky surface of a slide or a petri dish due to the gravitational pull. So this comes under the sedimentation methods. And next is the inertial methods. Inertial methods is the wind which carries the microorganisms gets settled into the sticky surface of the sampler, whether it is a slide or a strip. So in this inertial methods, we are going to study about the Boehm sampler and vertical cylinder trap. Next comes the airflow impactors. So in this airflow impactors, the vacuum pump is used to suck the atmospheric air. And when you're sucking the atmospheric air, along with it, the microorganisms also is being sucked, and it is impact on the petri dish or a slide which is inside the impactors. So in this, we are going to see about the Burkhardt personal sampler, Burkhardt sampler, aerosol cassette, liquid impingers, Anderson samplers. So when we talk about the cascade impactors, mainly we'll see the different stages of Anderson sampler. There is a single stage, 2-stage, and 6-stage Anderson sampler, which comes under the cascade impactors, and the multi-stage cascade impactors. So the cascade impactors also falls under the airflow impactors. So next comes the sampling through filtration. So here, the airborne microorganisms are collected in a membrane filter of different pore size in a cassette. So that is called as sampling through filtration. Next is sampling using aircraft. So the aircraft, the normal aircraft, the domestic, or the aircraft which carries the luggages can be used for sampling the airborne microbes as well as the volatile organic compounds which is present in the atmosphere. Next comes the sampling using UAV, the unmanned aerial vehicle. It is of two types, the fixed wing and the quadrotor. So all these comes under sampling using unmanned aerial vehicles, where the sampler has been fixed in this unmanned aerial vehicles and air sampling is done for microbes, for uh, for microbes such as bacteria, fungi, and the volatile organic for bacteria and fungi. And when we go see about the sedimentation method, the first thing is the sedimentation method is the gravity petri dish and gravity slide method. So first thing is the gravity petri dish method. In this gravity petri dish method, the petri dish containing nutrient agar or potato dextrose agar. If we want to isolate bacterial colonies, then we go in for nutrient agar medium in the petri dish. If you want to isolate a fungi, we go in for potato dextrose agar, and we expose the petri dish in a table. That is why I said always air sampling should be done at 1 meter above ground level. That is very important. Uh, Principle which has to be followed when you're going for an air sampling with any air sampler. So the petri dish is kept on a table 1 meter above ground level and it is exposed for 10 to 15 minutes. And these plates can be incubated. And if you are incubating the petri dish containing nutrient agar medium, you have to monitor after 24 hours for the colonies. And if you're looking for a fungal airborne fungi, then you have to incubate the petri dish for 3 to 4 days, and you have to look for the fungal colonies. Here you can see the beautiful fungal colonies onto the petri dish, which is exposed into the atmosphere for 10 to 15 minutes. So this is called as gravity petri dish method. So just exposing the petri dish containing the medium in the atmosphere for 10 to 15 minutes, depending upon the site. So next is the gravity slide method. You can see here the slide with a sticky surface. Just remove the strip. There will be a sticky surface. Just expose the slide. The microorganisms which is found in the atmosphere get settled onto the sticky surface, and you can monitor the slide for the microbes. So next we go on to the inertial methods. I already said inertial methods is the wind carries the microorganisms. As it carries the microorganisms, uh, the wind carries the microorganisms and gets settled onto the sticky surface of the sampler. So this comes under the inertial methods. Inertial is the wind carrying the microorganisms and settling onto the sticky surface. It's called as inertial methods. In this, we are going to see about two different samplers, that is the Boehm's sampler and the vertical cylinder trap. So in the Boehm's sampler, you can see it is made of plastic. There is a funnel-shaped inlet for the air, and you can see the metal clamps which holds the slide. So here the air is sampled onto a sticky slide which is inserted into this slot, and it is held intact with the metal clamps. So there is a clip, plastic clip at the back of the sampler. So this can be kept in the clothes of a person who wants to go for a hair sampling. For example, if you take this sampler, if you want a sample, you can just clip it in your sari or in any clothes which you're wearing and just move around. Just forget about it and move around. This particular sample is done for 24 hours so that you can know a person how much he is exposed to microbes within 24 hours. You can just note it. So when you remove the slide and when you see through the microscope, you can see, you can know how much a person would have been exposed to the microorganism within that 24 hours of time. So this is the Boehm's personal sampler, which is made of plastic, and here the sticky slide is used for air sampling, and it is kept uh, clipped on the clothes and just move around, and this is comes under the inertial methods, the Boehm's personal sampler. Next is the vertical cylinder trap. So this vertical cylinder trap is nothing but a glass rod, which is of 30 centimeters height and 5 dia. And in this glass rod, the sticky surface is nothing but a strip, which is dipped in a molten wax and wound around this glass rod. And this glass rod is taken to the vertical cylinder trap. You can see the vertical cylinder trap with two, which is made of iron. And there is a slot for holding this glass cylinder in a vertical manner. And you can see the rain shield on the top, which protects the glass cylinder from rain. So you can see the slot which is holding the glass cylinder intact, and you just leave the cylinder for 24 hours, and you can see the wind carrying the microorganisms comes and settles here in the sticky surface. So this is called as inertial methods. So as the wind moves, it carries the microorganisms. So when it comes in contact with the sticky surface, the microorganisms settles onto the sticky surface. So you remove the sticky surface from the glass cylinder after 24 hours, then you mount it in a slide and you look for the microorganisms which is found in the sticky slide. So this comes under the inertial methods, the vertical cylinder trap, which is mostly used for the outdoor air sampling. Whereas Boehm's, it is clipped onto the person's clothing, and he just can move around, and it is mostly done for personal sampling. Whereas the vertical cylinder trap in the inertial method, it is used for outdoor sampling. Then comes the airflow impactors. In the airflow impactors, we see about the Burkhardt sampler, personal sampler, and Burkhardt sampler, and many other samplers which also comes under the airflow impactors. So here we see about the Burkhardt personal sampler. So this is a sampler which is made of alloy material, and you can see upper ring, kernel ring, and it weighs about 590 grams, and it is 96 mm in height and 88 mm in dia, and it has an rotating upper ring or upper kernel, and you can see the red dots here. These red dots, when it is in line, you can see a slot here. This slot is for the inserting the sticky slide, and when you turn it, you can either way turn the upper kernel ring to make the slide intact. At the base of the sampler, there is an on-off switch, and this is mostly operated indoor and outdoor. And this is the inlet where the air is sucked. It is battery operated. It has a rechargeable nickel cadmium battery. Once you recharge the battery, it can go continuously for 1.5 hours. So this is the Burkhardt personal sampler, and here the sticky slide is inserted into this slot, and this is the inlet, which is horizontal in nature, where it collects the air, and it is operated at 10 liters per minute. So with it, the air is collected 10 liters per minute by this Burkhardt personal air sampler. Then we go on for Burkhardt sampler. So this is mostly for outdoor sampling. You cannot use this Burkhardt sampler for indoor sampling. So this is for completely for the outdoor sampling. And the very important part in this Burkhardt sampler is the drum, which has a double-sided tape, which is sticky, which is wound around this drum. And this particular drum is fixed onto this sampler, and it moves 22 millimeter per hour. So it's a continuous air sampler which can which can run around for a week, for 7 days. The sampler can be operated in a continuous manner, day and night. And there is a rain shield to prevent the wash off of the sticky surface, and there is a wind pan which moves according to the wind direction. So this Burkhardt sampler, the sticky surface is the tape, transparent tape, which is wound around the drum. This is mostly used for the outdoor sampling of airborne pollen grains and the spores. In the Burkhardt personal sampler also, the spore types can be monitored. Next is the airflow impactors. In the airflow impactors, the aerosol cassettes. So this aerosol cassette, it is made of plastic. It has two cells, and it has inlet and outlet. So when you strip out this tape, which is covering the inlet, you can see the inlet, which is horizontal, and the collecting surface here is a sticky slide, and the other end of the inlet, you can see the sampler is this particular sampler is connected to a vacuum pump, which collects the air at 15 liters per minute. And here the sticky surface is just a cover slip. So this is operated for 10 to 15 minutes and with the help of a vacuum pump. So next is the liquid impinger, which is made of glass. And you can see, you can take any liquid medium. If you want to monitor bacteria, what is the bacteria in the atmosphere, if you want to know, you can take a bacterial liquid medium, that is the butane medium. Or if you want to study the fungi in the atmosphere, you can go in for a potato medium or subadose medium in this thing. And if you want to know the volatile organic compounds, then you can go in for solvents. So there is an inlet tube. At the other end of the inlet tube, you can see a cushion which helps in the safe landing of the microorganisms so that it will not lose the viability. And here, this particular thing is connected to the vacuum pump. This is also operated at 15 liters per minute. So this is called as liquid impinger, which also falls under the airflow impactors. Next is the Anderson samplers. So there are three different types of Anderson samplers: single stage, double stage, and 6-stage Anderson samplers, which is available. You can see the dismantled Anderson samplers. So these Anderson samplers are made of aluminium, and which can tolerate high temperature and pressure. So this is the inlet, the cone-shaped structure which you see here is inlet. So here is the inlet for the double stage, and this is the inlet for the 6-stage, which is in cone-shaped structure. And this particular sampler is operated using a vacuum pump, and the flow rate of this is 28.3 liters of air is being sucked by the sampler per minute. So this single stage air sampler is kept intact with the help of spring clamps, and it has a single stage. And in this single stage, you can see 400 orifices, which is laser cut. And the size of this orifice is 0.6 mm in size. So it takes up only the respirable fraction in this particular stage. And at the base of this sampler, you can see the slots for holding the petri dish. So the petri, if you want to go for fungal colony, you can take a fungal medium in the petri dish. If you want to isolate the bacteria from the atmosphere, then you go for bacterial medium. So the petri dish, plastic petri dish is kept in this base. Then it is covered with a single stage, and the whole sampler is kept intact using the spring clamps. So the air escape is prevented with the help of gasket. Uh, you can see here the black gaskets, which prevents the air which is flowing in coming out. Okay, so this is about the Anderson single stage sampler. Then the Anderson stage sampler, there are two stages. The first stage is 0.4 mm in size. The orifice size is 4 mm, and in the second stage, the size is 1.5 mm. And these two stages are kept intact with the help of dowel prints. And again, this sampler is connected to a vacuum pump, which sucks the air at 28.3 liters per minute. And this is the 6-stage Anderson sampler. You can see the 6 stages here. The base in this single stage and 2 stages, mostly plastic petri dishes are exposed. Plastic petri dishes with media is exposed. Whereas in the 6-stage sampler, glass petri dishes can be exposed. And you can see the dismantled 6-stage sampler. At the base, you can see the nostril, which is connected to the vacuum pump. And in each stage, you keep glass petri dishes, and the size of each stage varies. In the first stage, it is the size of the orifice is 1.1 to 0.6 to 1.1. In the first stage, it is 0.6 to 1.1. The second stage, it is 1.1 to 2.1. The third stage, the orifice size is 2.1 to 3.3. The fourth stage, the orifice size is 3.3 to 4.7. And in the fifth stage, it is 4.7 to 7. And in the in the fifth stage, and in the sixth stage, it is more than 7 microns in size. So this is the size of the orifices of all the 6 stages. So in each stage, you keep a glass petri dish and you make it intact. The whole sampler is made intact with the gaskets, and you can see the exhaust here, exhaust of air, and this particular nostril is connected to the vacuum pump. This is the air inlet, which is cone shaped. So this typically acts like our lungs. So the microorganisms which settle in the topmost stage has the ability to set the microorganism which settles in the nostrils, then the upper tracheal region, the lower tracheal region, uh, the lungs, the alveolar region. So each stage depicts our respiratory systems, and you can understand that this particular microorganisms has the ability to settle in this particular area of the lungs. So the most dangerous one is the one which is settled, the microorganism which settles at 0.6 to 1.1 stage, because this particular stage is the microorganisms are very small in size, which has the ability to travel into the alveolar region. So these are the 3 different types of Anderson sampler: the single stage, the 2-stage, and the 6-stage Anderson samplers. Next is the cascade impactor, that is the multi-stage cascade impactor, which consists of radial slots. I've not shown you the dismantled one here. So there are 9 stages in this cascade impactor, and the size of the weight of this particular sampler is 2 kg, and the height of the sampler is 28 centimeters in height, and the diameter of this is 6.4 dia, and there are about 9 stages in this sampler, and each stage has a radial slot, and the size of the slot goes like 0.16, 0.32, 0.53, 0.95, 1.7, 2.65, 4.1, 11, and 18 μm is the size of the radial slots in each stage. This is made of stainless steel, and you can see the slot here, which is connected to the vacuum pump, and this is the inlet. So there are different stages by which the air goes, and this whole sampler is made intact with the gasket rings. So this is the multi-stage cascade impactor. Next is sampling through filtration. So when we talk about the sampling through filtration, the filter membrane, this is the membrane which collects the airborne microorganisms, whether it is bacteria or fungi, is collected in this membrane. So this membrane filter cassette has 3 plastic cells. This is the inlet. Blue one is the inlet, and the red one is connected to the vacuum pump. It collects the air at 15 liters per minute, and this is through this the air enters, and this particular membrane is found in the middle cell, and when the air passes through the inlet, the microorganisms go settles into the membrane, and this is a red slot is connected to the vacuum pump. So this is a membrane filter cassette, which is for sampling through filtration. Next is the carpet check. This also comes under the sampling through filtration method, where here the membrane size is of various types, 0.8 to 4.5 to 5 μm, depending upon the area where you want to sample. This is also called as carpet check sampler. Here inside the sampling thing is the membrane, uh, which is of 0.8 μm to 5 μm in size. And this, for example, if you want to sample a carpet of 1 into 1 meter, you have to rub this sampler into the carpet. Again, this sampler is also operated using a vacuum pump, which collects the air at 15 liters per minute, and it is rubbed on the carpet, the left to right, and from top to bottom of 1 meter area, the dust is collected and it, in the membrane, and you can uh, incubate it, and you can know what are the microorganisms which is found in the carpet. So this carpet check, sampler, and membrane filter cassette comes under sampling through filtration. Both are operated using vacuum pump, and it collects the air at 15 liters per minute. And here the air gets, the microorganism gets deposited into a membrane filter, and this membrane filter is found in different pore size. So this is the sampling pump, and this is the charger, battery charger, which is used for the sampling pump. This is the flow rate. We can know how much of air being uh, sucked by this particular air sampler. This is mostly used for liquid impingers, for cassettes. So this is the vacuum pump, which is used for sampling cascade samplers and flow impactors, for Anderson samplers. For all these things, this vacuum pump is used. This again is connected to a flow meter. You can know at what rate the air is being sucked. Then sampling through aircraft. In this sampling through aircraft, you can see the normal aircraft where this is a passenger plane, or you can see the sampling tube which is connected to this aircraft, and it samples the microorganisms which is present in the atmosphere. Here is a picture I have shown you. The sampler, the sampler is nothing but a tube which is used to collect the microorganisms or the volatile organic compounds which is found in the atmosphere, can be monitored by fixing this air sampling tube into the aircraft. So the aircraft is also used for air sampling. Next comes the sampling using UAV, that is unmanned aerial vehicle. This is categorized into two. One is the fixed wing, the other one is the quadrotor. In the fixed wing, you can see it's a typical toy aeroplane like structure. This just flows through a particular area where you want to take an air sampling. So you can see in both the wings, the sampler is kept fixed in the wings, and the aeroplane takes off and just goes through the area and collects the sample within 1 minute and just lands. So this is called as fixed wing method. It cannot sample the area for a longer duration. Whereas in the quadrotor, you can see the sampler affixed to the quadrotor. This has the overing capacity, so it can stand in a particular place at a particular height, and it can sample the particular location. So that is the beauty of the quadrotor. So the samplers, the unmanned aerial vehicle, will be dealt in detail in the next unit, that is the next units. So with this, we come to an end of the air sampling. So thank you for patient listening. Thank you.